A few things to know about me before we begin. Discussing politics in general brings me absolutely no joy. I've always historically held a firm stance in the separation between church, state, and education. And second, statistics is not my forte. It's the area of math where I feel least confident. That all being said, 2 years ago, I decided to take my Algebra 2 curriculum, rearrange it, and take my statistics unit and bring it to the beginning of the year. Why? Well, it was fall 2016, the election. The opportunity to use real data, real-time data, in my class just seemed like too good of an opportunity to miss. And I was dealing with statistics, data, facts. These are truths. I could remain unbiased. I was also teaching computer science at the time, and computing in the news that I heard on a daily basis was filled with articles about the technological implications on politics. It's a lot harder to remain unbiased in that area. My students were engrossed in the conversation, and I couldn't help but join in. I decided instead of it being my duty to remain unbiased, it felt more like my responsibility to be a facilitator of these sorts of conversations. There were no lack of articles for my Algebra 2 class either. We would look at statistical studies, we would evaluate their methods, look for bias, and make meaning of the results. All of this led to a lesson on margin of error. I thought it had all the strong features of a good lesson. We looked at the formula, we looked at how the variables affected the result, we practiced, we pulled fictitious marbles from a bag and applied it. And then we had real-world data, right? The exciting main event of the lesson was the political data. I had just pulled up the most recent polling numbers and established it with my students, and the big question was, is there a clear winner? My students' reaction were all the same. Clinton's number's higher. Yeah, I asked, but what about the margin of error? Until I explicitly laid out the overlap to them, they didn't really acknowledge it. They didn't fully get it. Even so, they looked at it, looked at me, acknowledged I said something kind of important that they kind of understood, wrote down what I modeled on the board. There is no clear winner because. And that was it. Except I'm pretty sure at the end of the lesson, I actually said the following. I mean, there's a chance you could win. A few weeks later, the election crashed down upon us. That Wednesday, I was sent out for a PD. So on Thursday, when I returned back to school, I immediately went to my colleagues and asked, how are the students? How are they doing? Their reaction was not at all what I expected. The students were worried about you. My students thought I was so grief-stricken that I had missed school. And I mean, I was upset. I had begun the year taking so many risks, teaching a topic that I historically had avoided and struggled with through a lens I historically avoided, and this was my output. And worse, my students did not have the conceptual mathematical understanding I wanted them to have. At the end of that year, I was exhausted but went to Utah for PCMI, ready to be reinvigorated as a teacher. Part of the experience is putting on your student hat, getting to experience lessons, and one of the lessons that we did a deep dive into was exactly what I needed, margin of error. Okay. The lesson's available online. I encourage everyone to look it up, and I'm just going to share some highlights of how I've adapted it in my classroom. First of all, there's no more fictitious marbles, right? Students actually draw real trips as they enter the room, and we come up with one class sample. And students from a mystery bag try to determine what is the proportion of this mystery bag. From there, they gather in small groups and make more predictions of what they believe the proportion could be. Then they gather more data with simulations and technology. Altogether, eventually, taking these predictions, publicizing them as a class, and then as a class, we have to take all this information and come up with one final prediction of what we are confident the range of this mystery bag could be, the proportion of the mystery bag. It's interesting, as data emerged, right, all their predictions kept evolving. Some students became more and more confident. They knew that their results were correct, while others started questioning things more and more, being less and less confident. This year, I also had midterm data to work with. Instead of asking that question of, is there a clear winner? We looked at why others were making judgments. Why were they saying that some were solid, while others were leaning in toss-ups? And should we trust in what they're saying is going to happen? I still use this question in my class for the past 2 years. Only I use it to demonstrate my own mathematical vulnerability. Too often we just think we're using statistics to show truth, but we're actually using it to prove our own beliefs. Our emotions are getting in the way. My students saw this question and were focused on the sample proportion. That number was comforting to them. And even when I tried to raise the margin of error to question those results, I was unconvinced. I had demonstrated the mathematical concept, but it was just a fleeting truth. The margin of error lesson for me is a cautionary tale. I didn't see the full story of the data, but it's also important for me to think of the reverse, that somewhere else in the country, there's an educator who is teaching this exact same lesson, same formula, same data, same context. But instead of my blind optimism, they were using it and clinging on to margin of error with optimistic hope. So I've got the primaries next school year to consider, and then the presidential election too. And I wonder to myself if being the unbiased educator, the impartial mathematician, is worth pursuing. Thank you.